Our next speaker is Brian Ryzhikov of Odyssey Space Research. I think our sponsor, and this will be the Road to Commercial Class A.
All right, hi. I know the break is right after this, so I'm going to assume I have all 45 minutes. No, I'm just joking. So my name is Brian Ryzhikov. I'm one of the founders of Odyssey. So it's been a while since I did technical work, so I hope you don't expect a totally technical presentation. Now that said, there was a technical presentation yesterday, which we really did want to focus on the technical, and that team is still here. So if you have those kinds of questions, or if you want to see what's outside, you can go outside and look at it. So this is the Road to Commercial Class A. We have been working in the safety critical software environment for a very long time. And I'll give you a bit about Odyssey first, which I hope lays the groundwork for understanding why we got to where we are. So we started, frankly, 20 years ago as a GN&C company, Guidance Navigation Control. And we were focused on rendezvous and proximity operations at the very beginning. And that's how we got into the business of paying attention to safety. Now, in order to do guidance navigation control well, we had to do a lot of simulation and analysis. And so we had to do software and algorithms. So we got kind of good at doing algorithms and software. And the natural extension of doing the analysis is flight software. So we spent a lot of time taking those algorithms, and it was really focused on guidance navigation control originally, to develop flight software and really pieces of flight software for customers. And eventually, though, we broadened into adjacent areas where we're effectively doing all of flight software for certain customers. And that was a big step. And there's a Easter egg here. This is the logo on the website. I love this. People, I don't know if they pay attention, but the bits in the back of the flight software are OSR ASCII for Odyssey Space Research. So you have to look for those things. So the natural extension after that was to take the software and put it somewhere. So we started putting it onto platforms in customer sites, actually helping design those laboratories and test infrastructure for hosting the flight software, and even now hosting it at our facilities, which we have two. We have one in Houston, which is also why we were focused on human spaceflight, and an office in Boulder now. And so we got good at that. And the natural extension after you've got flight software running on platforms is to get into operations. Now, we've been true to our core areas. We don't do literally everything. Even in the human spaceflight operations, that's focused on flight dynamics, and we're actually part of a contract at Mission Control in Houston, performing some of those functions for space station and some of the other spacecraft. So, again, we're in Houston. Our initial focus was on human spaceflight. You can see the shadow of the space station in the background there. And it was really rendezvous with the International Space Station that got us rolling. And when Space Station was being built, it was being built principally by the Space Shuttle. And the Space Shuttle predated us. Now, that said, we did have some people with interesting experience from the Space Shuttle era, but it really predated us. And then the other spacecraft doing a lot of servicing to the space station are the Russian spacecraft. But those are also even older, and we did not participate except in an operational way with the Russian spacecraft. So the first two spacecraft to go to space station automated, so it was the European Space Agency ATV, the automated transfer vehicle. It docked with the International Space Station on the Russian segment, which is great fun. I have lots of stories. And the other spacecraft was the HTV, the H2, which is the Japanese rocket, H2 transfer vehicle by JAXA, the Japanese Aerospace Exploration Agency. So those two spacecraft were the original servicing spacecraft. But this was really done on the premise of agency to agency as part of the International Space Station barter. You give me this, I get time on space station, or what have you. And we worked very much on the safety side, on the integration side, but the last, well, what they call the last mile, which is actually longer than a mile, but it's the last part of flying to space station when space station cares about the safety criticality. These are unpiloted, uncrewed spacecraft, but they are flying to a crewed spacecraft. So once they enter this zone, they are essentially subject to a lot of the same requirements for safety criticality. So we really immersed ourselves, and they both flew fantastically. The ATV docked, and the HTV berthed. It was captured by the robotic arm. There were a lot of requirements. You get close to space station, reaches out, grabs you. Maybe you know all this, and it connects you to the space station through a port. So while this is going on, we're a pretty young company, and we start realizing that there's an opportunity for doing commercial things with the space station. And we actually did a funded SBIR for automated docking infrastructure to support commercial space development in 2004. So, you know, there's no such thing as an original good idea. So it was a good idea, but I think other people had that good idea, and it eventually came to fruition. So meanwhile, we're continuing to dabble, and we're doing silly things. So I call this exploring unconventional paradigm shift to COTS, commercial off-the-shelf products in space. And this was in 2011. So, you know, I like the iPhone, maybe you guys do too. The iPhone 4 had come out about a year before, and it had GPS. Of course, it won't work in space because of restrictions, but it had a gyro and an accelerometer, the first one to do that, and had a great interface, had a great camera. So we decided to do an application for space. We called it a space app. We coined the term. I think people use it all the time now. I wish we'd protected it somehow. But we flew the first space app, and it wasn't a toy or a game. It really did some things in space. We sort of harnessed our understanding of guidance, navigation, control. Because of export control, we couldn't make it that sophisticated, but actually it was a pretty sophisticated device for $500 and a lot of effort, and there's someone in the room who did that work with us. And it flew on STS-135, which happened to be the very last shuttle mission. And it actually got a lot of play and a lot of exposure. But importantly for me, it was this transition. We're moving away from the space shuttle to the next things. And I thought that was a really important sort of a boundary where things started to be different. So back to the space station, things are getting interesting. We were fortunate because of our history with these other spacecraft. We were invited to work with NASA and SpaceX on the Dragon, the first commercially developed spacecraft to fly the space station and deliver cargo. And it was groundbreaking, and it was ambitious, and there were a lot of people that said it was never going to happen, and it was, you know, a very difficult thing to do. And interestingly, so SpaceX was successful. There were actually 2 contracts awarded. The second contract was awarded to Rocket Plane Kistler, if those of you know your history, and we were part of the Rocket Plane Kistler team also, and they did not succeed financially. They had an interesting technical solution, but they were unable to secure enough money. NASA pretty cleverly took what was left over and invited additional bids, and it was Orbital that won that bid, and we heard from Josh earlier, so thank you, Josh, for laying the groundwork for this talk. So Orbital successfully delivered cargo with Cygnus. Another huge triumph. These are 2 different companies. Orbital had a legacy. They had a lot of capability. SpaceX was brand new. And even though Orbital started late, so to speak, and with less money, they delivered only a year later to space station, which is pretty impressive. So now, allow me to digress just a little bit. So we like to celebrate, right? Engineers, software people, we like to celebrate these victories. And I think at Swery here, it looks like it's cookies and muffins. But for us, the standard celebratory treat is donuts. So we actually had donuts made in the shape of an X for the SpaceX mission. And it was actually a lot of fun. Went to the donut shop, had a lot of trouble communicating. They didn't speak English. But I got them to make donuts in the shape of an X. And they were so proud when I went to pick them up. The entire kitchen came out and presented me this box of 36 X-shaped donuts, and it was a ton of fun. And so, of course, when Orbital was successful, we had donuts specially made in the shape of an O. So, moving forward, we got to Crew Dragon. Again, it's this legacy, this continuing legacy. And now once there's crew on board, you got to be safe the entire journey. It's no longer just that last mile. So you really got to be paying attention to the software all the time. Now, we had a different engagement. We're doing independent verification and validation, which gets you into the guts of safety critical software. And so we understood exactly how to do it, and we were invited to do that function. So COC 100, we're actually not invited to do that function. This is an independent, and they've had some struggles for sure. I was so disappointed, like everybody. I was at the Cape for the launch. I was ready to say something good, but now it's delayed to May 17th. But CST 100, another commercial. This is, again, an interesting choice, right? SpaceX Upstart clearly has a track record of some success. Boeing, the traditional crew development company. They built largely the space shuttle. They built a lot of the space station. And so this is interesting, again, this approach to commercial and keeping things in that sort of ballpark. Now, the next one to fly, I hope by the end of the year, is Dream Chaser. And we are now participating actively in the development of the flight software. And I'm pretty confident we're going to fly before the end of the year. There's a lot of things, weather, traffic models, rockets, matter a lot. But we're getting there, and we're very excited. This is another entrant. They have ideas in the future of a crew variant. So this is very interesting when you add another spacecraft to the commercial model. And there's a great story about the commercialization. CRS-1, and forgive me, Josh, I hope I get this right. So CRS-1, Orbital did start a little behind and with less money. So when CRS-1, which is the Commercial Resupply Services, the first cargo contract to space station, SpaceX bid and Orbital bid after they had successfully demonstrated. It turned out Orbital got a better price for the cargo they delivered. They were catching up. They had to make some money, and SpaceX was lower priced. That lasted for a certain number of years, and they recompeted for commercial resupply services too. That's the second contract, not necessarily two providers. Dream Chaser was added to the mix. During CRS-1, both Orbital and SpaceX had rockets explode. And so they wanted to preserve, for the long life of space station, opportunities for additional cargo. But it was commercial. There were competitors. When you look at the pricing, SpaceX is now the most expensive, Orbital is the least expensive, and Sierra is right in the middle. It's a really interesting, it doesn't take a lot to make the commercial activity really take force. Now we're into exploration. It's great. I'm old enough. My parents made me watch. They made me watch people walk on the moon, and I'm like, this is great. I want to do that. So we're very excited. We've been part of the Lockheed team since the competition, since 2006, and it flew. Artemis 1 flew, and it was outstanding. This picture, to me, captures what it is we're trying to do. This is a selfie that the spacecraft took with the moon closer than the Earth in the background. This is like the furthest a human-rated spacecraft, no humans on board yet, had made it, and it's outstanding. This is where we're going. Orion is a government project. It is being run much more traditionally, but that doesn't mean exploration is going to continue that way. In fact, when you look at what's going on now, and these are the big projects, it's commercial orbital transportation services, commercial resupply services, commercial crew program, commercial LEO destinations, commercial lunar payload services. These are all the focus. Now, when you move to exploration, they haven't thrown the commercial word around as much, but there's a ton of commercial activity. They have both the human landing system and what I call the second lander design. They have two different spacecraft that are going to go to the moon, and they're competing. NASA's doing it because they want to make sure they can get there, even if there are mishaps, even if there are delays, but they also want to know that it's going to be affordable and sustainable. This is a great way to go, and that's going to be true for the rovers and all the other infrastructure that NASA's building. But it's not constrained to just NASA. We heard about servicing in space. even for the commercial LEO destinations, there are companies that are not part of that that are building space stations. And make no mistake, they are well funded. So to make safety and mission critical software, all of us are using principally these documents. It depends, you know, if you're returning to the Earth, you have to pay attention to some of the DO 178, and then of course the NASA NPRs. You know, human-rated software, non-human rated software, we're typically in the Class A range, sometimes Class B, sometimes Class C. And then for DO 178, we're dealing with catastrophic and hazardous. But mostly, these are all custom solutions. Everyone, mostly because they're big enterprises. So big enterprises are investing big money or have invested big money to make solutions. And they're pretty much always in-house until now, because now there are more people involved. So we saw this after 20 years, actually after less than 20, because now we're 20. So for the last 2 or 3 years, we've been investing in creating commercial Class A-able, certifiable software for these applications with our institutional knowledge, our legacy, our experience, and a look ahead with modern software, modern processes, modern approaches. And basically, we've baked this in from the beginning. We knew that's what we wanted to do. So yes, we were designing reuse and applicability, but we knew we wanted it all to be Class A-able. We have safety features built in as it's written. We're providing libraries and utilities that are compliant. So you don't have to provide them. You don't have to wonder if what you're using is compliant. And we're doing extensive testing continually. It's this continuous integration and test environment throughout the development cycle. And we're leveraging automation a lot. In fact, this is an interesting story. We do the independent verification validation for both SpaceX and for Orbital, or well, Northrop now. And we, of course, they've flown many, many times. I should have probably had the number of times in my head here, but it's like 15, 20, 30 times altogether. So we automated all those processes. And having that automation available, it basically allowed us to take some steps backwards and then make it all implementable for this process. So the goal was to make sure we meet the intent of these standards, but by reducing overhead and reducing cost. So you heard yesterday, I think it was yesterday, about Encore. We really wanted that to be a technical discussion. So this is more a little rah, but it is important to know that the features built in are precisely to meet these Class A requirements. So it has to be deterministic, behaviorally deterministic. We support user-defined capability and distributed avionics architectures. We have a safe code execution at compile time checking and with integrated error handling. It's configurable and extensible for FDIR, so fault detection, isolation, recovery. That's a big deal when you are having people on board, and if you're doing things that don't have the time for someone to get data, figure out what's going on, and command some sort of reaction. And so we're also building in support for Byzantine fault-tolerant architectures and overall fault tolerance. This had to be accompanied by an ecosystem which supports all the testing, all the tooling, and all the automation so that we can get there cost effectively. So we have tools for moving data around, like commands and telemetry, tools for synchronizing testbed components and making sure everything is repeatable and behaviorally deterministic. Tools for creating and configuring your test beds and test scripts and defining test success criteria and running tests and all that. And we did design the ecosystem to work seamlessly with Encore, but we made it framework agnostic because frankly, we're also a CFS house. We're doing things with a lot of customers using core flight software. And that's a great answer for a lot of applications, but there's no reason it has to cost more. And of course, the ecosystem as a matter of purpose enables our commercial Class A processes. So together, this is a sales pitch a little bit. You know, we developed it with modern and streamlined approaches, and I make a very important distinction. All of us probably have war stories. I make a huge distinction between streamlining and cutting corners. Streamlining is great. Cutting corners is a disaster, and there's a long string of those, and it's important to know, and that's where our experience and our institutional knowledge has really played an important role. This is not a shrink wrap, here you go fly your spacecraft. This is intended to be a giant kickstart and reduce your technical risk, reduce your cost, and reduce your schedule. Because we have worked with the commercial companies who are funded by venture capital and all that, and they don't have the patience to build everything from the ground up. It's scalable and configurable, which is important because it offers that high reliability, even if you're not building safety critical applications. There's no reason not to use this if you want to reduce your technical risk and accelerate your development. And that's if it merits that kind of complexity or that kind of size. Again, there's other frameworks which are great and are good answers. And very importantly, so, we see what's out there. Some things are open source, some things are licensable. So our licensing approach, to be fair, this is sort of the reveal. So we're trying to be customer centric. Isn't necessarily a one-size-fits-all, but we are offering the so-called total control. I would say everyone wants vertical integration, but what they really want is total control. So we're offering that total control opportunity, if that's of interest. So milestones ahead. The first release is next month, and that's important for us. And it's already sort of available, if you will, but this is sort of the line in the sand. The second release will be in December of this year, and that's going to be feature complete with all the Class A cert evidence. So that's all through our automated process and everything. Stage, which is accompanying it, so Stage first release is going to be fall. I mean, certainly we're using it, and we've been using it for a long time. That's sort of a line in the sand. And it'll be feature complete with Class C cert. And if you're wondering, Class C cert is what you need in order to test and certify Class A software. And then the first Encore demo. So we're planning a flight demo. We're in discussion with several parties, and we have a plan to fly in 2025. And that's great. So I know all of you in software know this. Developing software, testing software, you can do all of that on the ground. We can get 99.5% of the way there without flying anything. But getting to flight forces you to dot every I and cross every T, and optically is important for customers. So we're going for a 2025 opportunity. And yesterday there was a teaser by our guy Jeff that we were going to make an announcement. There was a question. How come that didn't work? There was a question about when is it going to be applied. So we are proud to announce our first committed partner, which is the Astrolab LTV. So it was announced a few weeks ago. It's a lunar terrain vehicle. It is the unpressurized rover that will go to the moon and transport the crew around and do all kinds of activities and payload. We were selected and teamed with Astrolab a long time ago. The announcement came out in end of March, I believe, or maybe early April. So we're really excited. And this is a testament to how NASA approaching things. So there were 9 competitors. They awarded 3 initial contracts. This is competitive. And our team got the highest technical score. And so we're really excited about that. And it's going to be our first deployment. So that's it. Thank you, and thanks to Swery, and thanks to everybody, the work. And what's been interesting to me is the convergence on a few interesting topics like commercialization and safety critical software.
Could you explain to me what the term behaviorally deterministic means? I heard it yesterday, twice today. I've never heard that term before.
Yeah, I'm going to give you the layman's answer, and then I'm going to ask for help from the peanut gallery in the back. So we were calling it just deterministic, and we got a lot of questions about like low level timing, which is dependent on hardware. And so you can't guarantee how the hardware will behave, but we can guarantee how the software will behave. So that is the distinction, and I'm going to ask if that's a good enough answer from my friends in the back. I'm getting nods.
Okay. We'll take one online. Are you using any formal verification tools in your IV&V efforts, especially automated reasoning?
So everything we're doing for the IV&V has been homegrown and customized. And we have a pretty well converged process now that we're on CRS 20-something. I don't think there's any of those external tools. They didn't exist at the time, and we've converged on a very, actually, so the interesting thing about the IV&V, so sorry for digressing a little from the answer, we are, you know, when we were doing IV&V for what they call the demonstration flight, the first flights, the flights with the big block upgrades, they were very expensive. Everything was a custom. Now, I mean, our IV&V is quick, it's mostly automated, and it's cheap. So I don't know if those tools would be, and if you want a better answer, I can ask our team back home. It's been a while since I did any real work.